So I think a lot of this, 1, 5, 18, I think a lot of this should be pretty easy. We've done exponents. When you multiply, you add exponents. So this is going to be a 2 to the 5th or 32, right? 2 times 2 times 2 times 2 times 2, which is 32. You okay with that? Does that make sense? Everybody good? Okay, and then the second one, we'll get a 4 to the 6th. Now, I don't know what 4 to the 6th is. That's what calculus is made for, right? I don't know. What is 4 to the 6th? Big number. 46,656. Right?
Much math.
5 to the 5 to the 8th. And again, I don't know how big that is. That's a big number. 5 to the 8th. 390,625. X to the 8th, but we don't know what x is, so the beauty is we're done, right? That's the nice thing about an exponent as a variable, is that you don't know what the number is, so x to the 8th is it, okay? And we've done this before. Everybody's good on this, right? This is a nice little review. We're going to get into the negative ones coming up pretty soon, okay? So we divide, obviously 4 to the 1, right? Which is just 4. 2 to the 3rd, which is 8. You okay with the 8? 2 times 2 is 4 times 2 is 8. Okay, 2 times 2 is 4 times 2 is 8. X to the 3rd, and we don't know what x is, so we just leave it as x to the 3rd. And this one's just 1. Not 0, but just 1, right? Does that make sense? Because it's really 81 divided by 81. This one's really the same thing as 81 divided by 81, which is 1, okay? So, a power to a power. It's going to be 2 to the 8th. I don't know. What is 2 to the 8th? I'll tell you in a second. 2 to the 8th is 256.
Do we have to write down the numbers that they actually are?
No, I will take 2 to the 8th. Okay, I will. I'll take 2 to the 8th. 7 to the 6th. And I don't know what that is either. 7 to the 6th. 117,000. 649. Y to the 9th, right? Y to the 9th. And again, we don't know y, so we just leave it like that. Y is a variable. And then x to the 8th. Okay, thumbs up. We've done this before. You guys did this, Mr. Bards, right? Everybody agree?
Yeah.
Pretty easy, right? Okay, return the page. Not yet. Okay. All right. Okay. All right. Now, this one, we're going to go 2 squared times 5 squared, or what's an easier way to do this one?
4 times 5 squared.
How about 10 squared?
Wow.
Why not, right? Which would be just 100. And guess what? You get 4 times 25, which is 100. Math always works.
Wait, how isn't that 10 to the 4th though?
10 to the second.
Yeah, I know, but why is it 10 to the 4th?
Well, I just multiplied that and I got what? 10.
Oh. Okay.
Okay. This could be 20 to the 3rd or 5 to the 3rd times 4 to the 3rd. Either way, you should get an answer of, it's 23rd, 400 times 8,000? Hold on just a second, I'll tell you a second. 20 to the 3rd, yeah, 8,000, what do you know? Which would be 125 times 64, which is the same answer, 8,000, okay? A lot of kids miss this. You got to be careful. This is a 36a squared. Don't forget the 36, right? Don't forget the 36. You guys know where I got the 36 from? 6 squared, right? You guys agree? And same thing, a lot of kids will miss the 9, but don't forget the 9x squared, okay? Right? Okay, now we'll do the same thing on this, except we got to make sure we square the top and the bottom. Numerator, denominator. 4 ninths. Right? 64 27th. I'm going slowly because I want you to think about it. Okay, 4 to the 3rd over 3 to the 3rd, right? 4 to the 3rd is 4 times 4 times 4, which is 64. 3 1/3 is 3 times 3 times 3, which is 27. Okay. This one's going to be x cubed over 8. Okay, now think about the 8. The 8 came from 2 cubed, right? Came from 2 cubed, 2 times 2 times 2. So I get x cubed over 8, okay? Now like Ben said, if you leave the exponent, I would not mark it wrong. I wouldn't mark it wrong, okay? This is easy. It's just a4 over b4, right? How am I doing?
Good.
So let's generalize some rules, okay? So the first rule I would say is when you multiply like bases. Okay, multiply like bases. I mean if it's the same number, right? Or they're both x's or they're both y's, right? So when you're multiplying, if they're the same, you just add exponents, right? But they got to be the same, like bases. So multiply like bases, we're going to add exponents, okay? Yeah, and that would be just like, I guess it'd be like this one here, if I have x squared, x3, right? Like bases, they're both x and x, right? If we divide like bases, they have to be the same, x and x, or y and y, or 4 and 4, 3 and 3, right? It's going to be the same base. Then we subtract exponents. Finally, if we have a base that has an exponent to an exponent, okay, base has an exponent to an exponent. Let's multiply. Multiply exponents. Okay, those would be my rules. Okay, we got 3 rules, right? We add exponents when we multiply like bases. We subtract exponents when we divide same bases. And we multiply when we have an exponent to an exponent, okay? All right, number 3. There are 3 cubed, small cubes in the cube below, okay? So there's 3 of these in this cube below, okay? Write an expression for the number of small cubes in the large cube at the right, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 by 9 by 9, right? You guys agree with that? So what we have is, you ready? So the volume of this would be 9 times 9 times 9, right? How am I doing? Am I okay? Right? Yeah. Okay, so that's no big deal, but they really want me to do it in terms of 3's, right? So we can change this number into a 3. Can we change this number to a 3? What would that be as a 3? 3 what? 3 what? 3 squared. And this could be what?
3 squared.
And this could be... So we could rewrite the volume as 3 squared times 3 squared times 3 squared, right? You guys agree with that? Which means it would be 3 to the 6th. Okay? Or 3 to the 3rd squared. And I did that because I really wanted this. It could be 9 cubed, yes. Yeah. And I would not take that. I would take that. That's a completely good answer. They really wanted me, Landon, to try and put it as a 3 cubed. So that was, well, they just wanted me to. So we can see how many of these are in here.
So many more steps.
Yeah, I agree. Okay, Ellie, what am I going to do? All right, turn off the video.